2 million. Hey, that's pretty good. That's a lot of sales. 2 million. Oh man, every second, every second, about 2 million per second. All right, now, right here, destroyed by phagocytic macrophages, which are derived from monocytes. They dispose of aged, wore-out blood cells. A key area would be that macrophages are especially found like the Kupffer cells in the liver. There's also a macrophage in the spleen. Now, the spleen is primarily involved in defective red blood cells. And also the bone marrow will also destroy certain red blood cells. All right, now, right here, everybody, right here, the spleen is important. I put it in defective. For some reason, defective. Maybe if there's some sickle cell anemic cells, sickle cell anemia, maybe just try to destroy some of those. All right, now right here, number of abnormal cells in the blood. I just have that in there. I don't know much about that. That's in in some of the literature. If the spleen, usually the spleen is not. I tell you where the spleen injuries come in automobile accident where somebody's hit from behind, or they're thrown into the wheel and it damages the spleen. The spleen has to be removed. And so you'd have to look into more about that as far as the number of abnormal cells that might come along from that. But anyway, I had that in there. Now right here, hemoglobin destruction. Okay, what is globin? Now if I go too fast right here, tell me to slow down because this stuff is kind of important. Globin protein is broken down to component amino acids. In other words, the globin is protein. Hemoglobin, heme the non-protein, globin the protein portion. Proteins are all composed of AAs, amino acids. They're all composed of amino acids. And so these amino acids may be used in the synthesis of other proteins, whatever. Where does protein synthesis occur? On the ribosome. Remember the ribosomes are sites of protein synthesis? You remember kind of vaguely, we didn't talk a whole lot about that. But globin, just remember, when a blood cell wears out, the blood cell, the red blood cell is broken down. What are major components of the blood cell? Hemoglobin, over 280 million molecules per RBC is hemoglobin. Well, the globin is the protein part. Okay, what's a protein? Amino acids. These amino acids can be chopped up. They can be used to make more protein. They can be. All right, now right here, everybody, heme phase. This gets a little more involved. Iron. Okay, iron, y'all, to make a long story short, very short, iron is liberated, is picked up by a plasma protein called ferritin. Transferrin. Picked up by a substance called transferrin. Transferrin will carry the iron to the liver for storage in the form of a stuff called ferritin, or it will transport it directly to bone marrow if it needs it. So right here, iron, now look at this. Iron is liberated and combines with a plasma protein, now say transferrin. This is transferred to the RBC production centers, or where are the RBC production centers? Where's one RBC production center? Where's one? Where's one? Come on, bone marrow where?
Proximal end of the
femur. Good deal, proximal end of the femur. The sternum, the ribs, the os coxa, the vertebra. These are red blood cell production centers. These are key production centers. I asked a question about that one time. Which of the following would not be a key place where red blood cells are produced? I listed some of those and I put distal end of the femur. Distal end of the femur ain't. But the proximal end is. Proximal end of the femur is a key area for blood cell production. All right, now right here are stored in the, let's say in the liver cells in the form of an iron protein complex called ferritin. Transferrin, that's easy to remember. Transferrin transports, ferritin stores. So that's pretty easy to remember. That's pretty easy to hang on to. All right? Now then, right here, everybody, look at this. The heme remainder. All right, now then, okay, now look at this. All right, heme remainder is converted to biliverdin. Biliverdin is converted to bilirubin. Bilirubin goes by way of the bile to the intestine. Bacteria in the intestine convert bilirubin to urobilinogen. A certain amount of that is converted to a stuff called stereocylin, and it goes out in the feces. All right, so here's the heme remainder. Heme remainder converted to bilirubin. It's converted to bilirubin. Bilirubin enters the blood, and I asked you that on this test too. On the practice exam, did you see on the practice exam, bilirubin binds to who in the blood? And the answer's the albumin. That's on your practice exam. That's one of the questions right there. What is albumin? Albumin is a protein in the blood that gives blood its viscosity. Gives it its viscosity. It's a protein in plasma. That's what albumins are. And they're primarily responsible for viscosity. Okay? So then this comes, now let me show you, coming on down right here. Bilirubin is eventually taken up by the liver, excreted in bile. Bilirubin is converted to urobilinogen. That also shows, when I get my blood work done, now what I'm going to do this week, Brett, what I'm going to do this week, I'm going to try to make my reports come out as good as possible.